Look at the structure of sodium chloride, or you see the bonding in magnesium chloride, or you see the bonding in calcium oxide. These compounds have this particular structure. Why do they have a particular shape? We learn what are the conditions required for getting such shapes for a compound such as sodium chloride, magnesium chloride, or calcium oxide. What are the properties of this compound? What are the reasons behind that? So let's study the properties of ionic compounds, or we study the ionic bond in detail. So we start with the formation of sodium chloride. So what is the formula of sodium chloride? It is NaCl. Sodium chloride, NaCl. Okay, why do we call it is an ionic compound? Let us see. You know the atomic number of sodium is 11. Atomic number of sodium is 11. So it has an electronic configuration 281. See, there is only one electron in the outer shell. So sodium loses that one electron so that it forms a positive ion. Okay, we call the positive ion a cation. Okay, we can call it as a cation or a sodium ion. You see, here we can have the total number of electrons in different shells. 281, total 11 electrons are there. Okay. See here how many electrons are there. After losing one electron, we can have 2, 8, 10 electrons are there. Then where does this charge plus 1 come from? Since the atomic number is 11, sodium has 11 protons. The charge of a proton is positive one. Since we have 11 protons, there are 11 positive charge. 11 negative charge particles are called electrons, so the total charge is 0. Comes on the right side. There is no change in the number of protons. So number of protons are still 11 on the right side of the reaction. So see here 10 electrons while there are 11 protons. That means one proton extra, that means one positive charge extra. That is given here. Okay. The same way we see how does a chlorine atom form a chloride ion. See, chlorine has an atomic number 17. So that is got, it has got an electronic configuration 2, 8, 7. Okay. And how many protons are there? The number of protons are 17. So 17 electrons and 17 protons. That means 17 negatively charged particles. Same way 17 positively charged particles. So the net charge of an atom is 0. See how many electrons are there in the outer shell. There are 7 electrons. So what does an atom do? The atom gains electrons. So it's to form what? So it's to form octet. It gains 1 electron to the outer shell. Okay. So that chlorine atom forms a chloride ion. What would be the charge here? So let us see what the charge there. So see the number of electrons are. Since 1 electron is added to the outer shell, electronic configuration can be 2, 8, 8. And there is same number of protons. There is no change in the number of protons. Still it is 17. You see 18 electrons while there are 17 protons. That means 1 electron extra. That means 1 negative charge that is to be given here minus 1. Okay. So we call it as an anion. Okay. Or we can call it as a chloride ion. So we have got two equations. One is for the formation of sodium ion. The second equation we see the formation of chloride ion. That means if we combine the sodium ion with the chloride ion, we get a compound sodium chloride. That means between sodium and chlorine there is a bond, there is an electrovalent bond, or we say there is an attraction between two opposite charges, sodium with a positive charge and chlorine with a negative charge. There is an attraction between the opposite charges making sodium attach towards the chlorine. So we say this bond an electrovalent bond, or we call it as an ionic bond. See the orbit structures of sodium and chlorine on the board. You see the K shell, sodium has 2 electrons in its K shell. The same way 2, 4, 6, 8 electrons in the L shell, and in the M shell there is only one electron, 2 comma 8 comma 1. Sodium has electronic configuration 2 comma 8 comma 1. So here you see K shell 2, L shell 2, 4, 6, 8, 2 comma 8 comma and 2, 4, 6 and 1, 7, 2 comma 8 comma 7. Okay. So what they say, since there is only one electron in the outer shell, that one electron sodium loses to the chlorine. Okay, sodium loses its one electron in the M shell to the chlorine. As I have already told you, sodium loses its one electron from its outer shell the same way chlorine gains that electron to its outer shell. See here, sodium loses, chlorine gains. So after that, we see sodium becomes sodium ion. That means 2 comma 8. That we make here. And chlorine becomes chloride ion. That means 2 comma 8 comma 8. Here you see the structure of sodium ion with the 2 shell, and here you see chloride ion with the 3 shells, and there are 8 electrons in its outer shell as it has gained 1 electron. Okay, and since it lost 1 electron, we give 1 positive charge, and chloride ion it gained 1 electron, so minus 1 electron. As a positive charge and a negative charge, there can be attraction between these two, and it can be joined, attached with energy or a force that can be called a Coulomb force. It can be represented such a way. We can write here Coulomb force. Now you see the electron dot structure of sodium chloride. Dot structure means we represent the outer electron, only the outer shell and the outer electron by a dot. Okay, don't forget these two words. We represent only outer orbit, and we say valence electron, or we say valence electron. It can be represented by dot or dots. Okay. You see, sodium has 1 electron in the outer shell. What is the electronic configuration of sodium? Sodium has 2 comma 8 comma 1. What we represent? We represent only the valence electron. Only 1 electron in the outer shell. So we put a dot here. Plus it combines with whom? Combines with chlorine. Sodium chloride, chlorine. So what is the electronic configuration of chlorine? 2 comma 8 comma 7. So what we represent? We take only the 7. So how do we write? We write normally the electrons as pairs. Okay, 2 electron, 2 electron, 2 electron and 1 electron. So we know what? Sodium loses its 1 electron. That who gains? Chlorine gains. So after losing or gains, sodium becomes sodium ion. So chlorine gained 1 electron. So chlorine becomes 2, 4, 6 and 8. So we give a minus charge. See the next compound, magnesium chloride. What is the formula of magnesium chloride? MgCl2, magnesium chloride. So first we write the ion formation of magnesium. Magnesium with the atomic number 12. So we write 2 comma 8 comma 2. Since 2 electrons are there in the outer shell, it loses the 2 electrons, so that you form magnesium ion 2 plus. Okay, so the electronic configuration can be 2 comma 8. So how do we write the ion formation of chlorine? We have already learned chlorine has 17 electrons in its outer shell. That means 2 comma 8 comma 7. So it gains 1 electron from chloride ion. Okay, that means 2 comma 8 comma 8. So now we have got a cation, magnesium ion, and an anion, chloride ion. So we are going to combine magnesium ion and the chloride ion, so as to get what? Magnesium chloride. How do we write the formula? Magnesium combines with chlorine. Chlorine is a diatomic element, gives magnesium chloride, MgCl2. So balance the equation, Mg plus, okay, it is correct, MgCl2. That means magnesium 2 plus combines with two chloride ions. Two chloride ions gives magnesium chloride. Let's see the orbit structure. Now we have the magnesium atom with electronic configuration 2A2, and we have two chlorine atoms. There are two chloride ions are there, so two chlorine atoms required. Two chlorine atoms. Okay, this one chlorine atom and the another chlorine atom. Here the nucleus. It is a nucleus. It is a nucleus. Okay, so what does magnesium do? Magnesium loses its one electron to one chlorine and another electron to the another chlorine. So chlorine gains one electron from magnesium and the another electron gained by the second chlorine. We see after the reaction. Magnesium loses its last shell. Magnesium nucleus. We put him in the bracket. The same way we have two chloride ions. First chloride comes here and the second chloride ion comes here. Chlorine 1, chlorine 1. It is a nucleus. So now we have the magnesium ion with the two positive charge. We have two chloride ion with the minus here, and here also we add the minus. Since there are two minus, two positive, there can be an attraction between the positive and negative. That attraction is represented by this arrow mark. Okay, and that force is called what? Coulomb force, that we write here, C-O-U-L-O-M, the Coulomb force. Okay, and also he label here is 2H. Okay, magnesium ion, 2H, and here we can write 2 chloride ion, that means 2, 8, H. Okay, so it is the entire formation of magnesium chloride molecule. Now we see the electron dot structure of magnesium chloride. See, I have already told you, when we make a dot structure, we make only the valence electrons. So we have two valence electrons are there in the outer shell of magnesium. Plus, for the formation of magnesium chloride, we need two chlorine. Okay, we write the first chlorine with 2, 4, 6 and 7. So one electron goes here. The same with the second chlorine. 2, 4, 6, 7. The second chlorine goes there. Okay. So what we get? Magnesium lost its 2 electron. Okay, it loses its 2 electrons, so that to form magnesium 2+. And now we have 2 chlorine there. We make 2 chloride ion. Okay, they got 1 electron each. So we write 1, 2, 3, 4, 5, 6, 7, 8, and we can have a minus charge. Okay, or the same we write as Mg2+. Or we can write chlorine 2, 4, 6, 8 to here also. Now we see another example, calcium oxide. What is the formula of calcium oxide? CaO. Okay. We can easily make the formula if you know the valencies. Calcium with valency 2+ and oxygen with valency 2-. Just crisscross, we got Ca2 and O2. It can be divided with a common factor 2, so you got the formula CaO, a crisscross method. So that you must know the valencies of all the elements. Okay, we see the formation of calcium ion. Calcium has atomic number 20, so we write 2, 8, 8, 2. Since 2 electrons are the outer shell, it loses 2 electrons, so that form calcium 2+. Electronic configuration 2, 8, 8. Okay, of course we see the ion formation of oxygen. Oxygen got 2, 6, atomic number 8, so 2, 6. It has 6 electrons in the outer shell, so it gains 2 electrons. Plus 2 electrons, it gives oxygen 2-. So that the electronic configuration is 2, 8, 6 plus these 2, it becomes 8. So we have the 2 ions, calcium 2+ and oxygen 2-. Just to simply combine calcium 2+ plus oxygen 2-. minus. So we got calcium oxide. Okay, which is an ionic compound, but it also can be called electrovalent compound. Okay, now we see the orbit structure. The nucleus of calcium, K shell. So it combines what? It combines to oxygen. Oxygen, nucleus of oxygen with 2 electrons and 6 electrons. Okay. 2. So it is the nucleus of oxygen. First shell with 2 electrons, second shell with 6 electrons. That means 1, 2, 3, 4, 5, 6. Okay. So 1 electron can be given from here or 1 can be from here. So what we get? Losing or gaining of electrons, we see first we get the calcium ion with electronic configuration 2, 8, 8. 2, 8, 8. Okay. So we get the calcium here. First shell, second shell, and the third shell. Here we have 2 electron. Here we have 8, 2, 4, 6, and 8. And the last shell, of course, there are 8, 2, 4, 6, and 8. And we have oxygen. Another bracket, square bracket, we put oxygen there. It is the nucleus of oxygen. Electronic configuration, it gains 2 electrons, 2, 8. So first shell there are 2 and the second shell 8 electrons, 2, 4, 6 and 8. So we give here 2 minus and we give here 2 plus. Since there are positive charges and equal number of positive charges and negative charges, so there is an attraction. So, or it can be attracted by a force. That force is called a Coulomb force. So we write here Coulomb force with a arrow mark. Okay, a pair of arrow mark. One towards the right and from negative to the positive side. We write here Coulomb force. Coulomb force. So we see the formation of calcium oxide, which is of course an electrovalent compound. We see the dot structure of calcium oxide. Calcium with the 2 electrons in the outer shell. 1, 2 plus oxygen, 6 electrons are there in the outer shell. 2, 4, 6. So we show like this with 2 arrow marks. That means these 2 electrons are given to oxygen. So calcium become calcium 2 plus and oxygen become oxygen 2 minus with 8 electrons. 2, 4, 6, 8 and 2 minus. Okay. So this is a dot structure of calcium oxide. There are mainly 3 conditions required for the formation of an electrovalent bond. First one, low ionization potential. Which element shows the low ionization potential? It is metals. Or the left side of the periodic table, they are the metals. So metals have low ionization potential so that they can easily form cations. Second one is that high electronegativity differences. You see sodium and chlorine. What is the difference? What is the electronegativity value of sodium? It is 0.9 and what about chlorine? It is 3. So high difference in the electronegativity values. So if there is much difference there, they can easily form ion. Sodium can easily form sodium ion, chlorine can easily form chloride ion. The third condition is that high electron affinity. Normally, which elements do show high electron affinity? They are the elements of right side of the periodic table. That means non-metals. Non-metals especially shows high electron affinity so that they can easily form anions. Today we learned the formation of 3 electrovalent compounds: sodium chloride, magnesium chloride and calcium oxide. I hope this video was helpful and we will study about the covalent bonds in our coming sessions. Thank you.